Hey everyone, my name is Priyanka. Me and my group is going to present on the MongoDB NoSQL database. Since the data is evolving at a very high pace, unstructured data from sources like social network, healthcare, science, videos, and photography is being generated at a speed so high that it has become utmost important to intelligently handle such data. NoSQL comes to rescue with their ability to handle huge amount of data, structured or unstructured with ease. NoSQL databases are non-relational databases that offer flexible or no schema. Unless the traditional database, NoSQL doesn't require data normalization and the ER mapping. While handling rapidly growing data, relational databases need scaling up the storage by upgrading hardware, which becomes expensive and cumbersome. NoSQL solves this problem by distributing the data over different servers as it supports horizontal scaling. This makes NoSQL highly scalable and allows the use of database in a distributed environment. Most of the NoSQL databases are open source and offer cost-efficient solution. Therefore, many small-scale and fast-growing companies opt for NoSQL management database. MongoDB is one of the most widely used NoSQL database. It provides high-performance solution to its user and has a simple schemaless data storage in the form of documents. MongoDB supports ad hoc queries like search by field, query by range, search by regex, and much more. MongoDB provides great indexing option for effective query optimization. It also supports aggregation frameworks, MapReduce, through which one can easily run various data processes in parallel over different cores or machine and filter, sort, and summarize the data into bigger data sets. In order to scale the data horizontally, MongoDB implements sharding, which is the mechanism to partition huge data sets into smaller data sets that are faster in processing, easier to manage, and distribute data over different machines. It also helps in load balancing. Another key feature of MongoDB is its master slave replication. In this technique, there is one primary node which has the power to read and write, and the other secondary node can just read or back up the data. This feature is used when the data is being distributed over different servers, and while doing so, data duplication is also done in order to keep the database up and running in case of hardware failures. MongoDB stores data in the BSON format, and all the files being stored could either be of varying size or they all could have a fixed size, making them capped collections. This table shows the basic differences between MongoDB and RDBMS. Moving on to the MongoDB application, we have implemented a review system. The review system in real world is a part of e-commerce website where the user can buy various products. We have two types of users in our system. One being the users that can buy the products and give the reviews, and other is the admin, which basically does all the content management system. Let's take a look at the demo to get a better understanding. For the demo, I just run the index file and it loads the login window. I'll just use one of our test users' credentials and log into our system. So as soon as the user logs in, it goes to the user dashboard, which has two features: to add a review and view the review. In add a review, basically there's a product name where users basically use different can give a review of different products. Suppose I use the candle and say smells good, good quality, and lasts long, and give a star rating of 4 to a ad review. Now, if I go to my database and refresh it, it basically adds the review in our reviewed collection, and in our product, it adds the review ID. So if I go to the candle, basically it would add the review ID in the product table. So this is how our add a review works for the user. Another feature is the viewed reviews, where the user can basically just see all the reviews other users have given. The second type of user in our system is the admin, which has only one login credentials of admin. So if he logs in, it has basically more features than the user. So if you want, he can add the product like a table which comes in the home category, and color is brown, size weight is 80 pounds. So if I add this product and go into our product database and refresh it, it will basically add the table into our product collection. So this is how the admins can basically add a product into our system. Another feature includes editing the product details. So if we want to edit the table which we just added, the name is table, the category is home, and suppose the color is now black, and the weight is again 80 kgs as previous. So if you go to the reviews database and just refresh it, it would change. It has changed the color attribute. So this is how the user can edit the product details. If the user wants to delete a specific product, he can select the product. Suppose I want to delete the lamp, and I do delete the lamp. And if I go to a database which shows the lamp here, and if I refresh it, it's gone. So this is how we have implemented the basic CRUD functionalities of creating, editing, deleting, and updating. So this was a small demo of our review system. Now my colleague Kriti is gonna take over.
Data storage in MongoDB is very different from the traditional RDBMS. In MongoDB, data is stored in the form of key value pairs and organized into files or documents. These documents are stored in BSIN format, which is a lightweight binary representation of the JSON format. This data storage format makes the database schema more flexible and performance efficient. Relational databases have a fixed schema in contrast to the NoSQL databases, and the data is stored in the form of a table. The headers of the table are the attribute names, and the rows of the table store the values of the different records of the database. Indexing. Indexing helps in enhancing the performance of the queries. MongoDB supports indexing at collection level on any field or subfield. The unique index on the ID field is by default and cannot be dropped. This is to ensure that no duplicate records are inserted into the collection. MongoDB supports user-defined index, like the single field index, which creates a sorted index on a single field, or the compound index, which creates index on multiple fields. There are other indexes like multi-key index, which is created on those fields that are of array data type. Then we have the geospatial index that can be created to query on data related to geospatial coordinates. Text index helps to query based on string or text content in a collection. Hash index is created by storing the hash values of the indexed field values. Such index is used to perform hash-based equality search. Index options in RDBMS are mainly ordered index or the hash index. These indexes can be either on a single field or multiple fields. By default, the index of a table is set to the primary key, but unlike MongoDB, it can be removed and a different column can be selected as the index. Now, this is a code snippet where we have created an index on the username of customer collection using the createIndex function. There are about 1 million customer records in the database, and all of the usernames are unique. Now here we can see the result of the query with and without the index. In the first one, in the first image, we are not using the index, and we can see that it takes about 979 milliseconds to execute the query. And when we use the index, we can see that the query took only 81 milliseconds to execute. Let's talk about query processing. Now, similar to RDBMS, MongoDB engines processes each query and generates a query plan based on the indexes available. The query engines utilize these plans to execute the query. For queries with multiple valid plans, the query optimizer stores the query plan in cache to avoid recomputation. In RDBMS, query plans are called execution plans as they're merely the steps that are followed while executing the query. The first part of the query plan is the number of the execution steps to get to the query result, where each step represents a database operation. The other part is the flow between the various execution steps. Now, these plans could be sequential or branched, which represents a single data source or multiple data sources, respectively. Now, in MongoDB, the query planner first checks for cache entry of the query in process. If the cache does not exist, the candidate query plans are generated, and most optimum plan among those query plans is used to generate the results. If the cache exists, the query planner uses a replanning mechanism to evaluate its performance. The evaluation result is just a pass or a fail decision. So if the decision is pass, it generates the result. If the decision is fail, the query planner goes through the same process as for the non-cached query. Now, query optimization. In order to have a smooth running application, one needs to make sure that the proper optimization of queries is performed so that the response time is minimum. In general, for query optimization, the system estimates the cost of each query plan that leads to the final result and chooses the best one. In RDBMS, the cost of each operation and the size of the result obtained by each operation should be calculated. With the help of reduction factors, the cost of single relational plans can be easily estimated. For queries that involve multiple relations, left deep join trees are considered, or modifications of the single relation optimization plans can be used. MongoDB provides a database profiler that calculates the cost of each operation and evaluates the performance of the current plan. This can also be done using the current operation function. And there's another function, that is the explain function, which displays the query plan along with other execution stats. Now, here on the next slide, we can see the query plan using the explain function. So it was obtained when we used the explain function on a query to select the record with a particular username. We can also see other information like the winning plan, rejected plans, and other execution statistics for this query. So as a user of MongoDB, there are many query optimization techniques that should be followed to make the application efficient and responsive. The first one is to create indexes. Adding and using indexes reduces the I/O costs and enhances the performance of queries. The index could also be rebuilt or removed according to the requirement. Second is aggregation pipelines can be used to pass the result of one query directly to the other without creating temporary storage for saving the intermediate result. Next, to reduce the network demand, a limit should be applied to the query results provided there has been a limit given by the user. Now, a limit to the number of fields can also be set by making use of projection and obtaining only those fields that are required in the final result. And finally, by making the use of hint function, The query optimizer will be forced to choose the index mentioned in the function and not the index calculated by the system. So now Amit is going to take over.
Thank you, Kriti. Greetings, I'm Amit Jaisingani. Now I will be talking on transaction management, security support, and why MongoDB is a better choice for our project. So let's get started. A transaction is a unit of work which generally involves both read and write operations. For consistency across a transaction, a database follows certain norms such as atomicity. Unlike RDBMS, atomicity in MongoDB is implemented differently for query involving single and multiple documents. On a single document, a write operation is atomic even if the documents contain multiple embedded documents in itself. While in a multiple document write operation, even if the entire operation is not atomic, the write operation on each individual document in it is atomic in nature. However, starting version of 4.0 for MongoDB, it started supporting atomicity for multi-document transaction as well. This is done on replica sets. Multiple document transactions are similar to RDBMS transaction in terms of all or nothing rule. That means everything will be executed or everything will be reverted back if there is an error. However, an atomic write operation on multiple documents is significantly costlier than the operation on a single document. Hence, the official MongoDB documentation recommends the denormalized data model for optimal transactions on data. That is, minimizing the number of multi-document transactions will increase the number of atomic single document transactions. In MongoDB, a start and end of a transaction are marked by a session. There are few rules in MongoDB which a transaction has to abide to while executing operations. Rules involves restrictions on operations involving metadata, cursor, scope of transaction, etc. For example, in the multi-document transaction, operations which affect metadata, that is catalog, like creating or deleting database or index are restricted. In RDBMS, a general approach to retry transaction is to roll back all statements until the error point and retry rollback statements based on the error. While in MongoDB, regardless of the retry writes property, individual write operations are not allowed, but the entire transaction can be retried. Like RDBMS in MongoDB, returned error can have labels describing the error in more detail. MongoDB and RDBMS both follow asset properties, but MongoDB emphasizes on CAP theorem, where CAP stands for consistency, availability, and partition tolerance. It is difficult to achieve all these properties, hence there are trade-offs while dealing with performance of distributed systems. Security of a database can be determined in terms of availability of data to authenticated users for reading and writing operations. RDBMS follow ACID properties in order to maintain integrity and consistency across the system. Security features include encrypted communication, access-based control for row and attributes, as well as role-based and user-based control access. While in MongoDB, the MongoDB provides authentication methods, role-based access control, transport level security, secure sockets layer configuration, and for enterprise edition only Kerberos and LDAP proxy authentication. Since MongoDB does not have and schema in its structure, so it does not provide access based on rows and attributes or relations like in RDBMS. In order to help users to achieve correct security measures provided, MongoDB provides a checklist of recommended security measures to protect MongoDB instance, which can be found on MongoDB documentation. Now, why use MongoDB for review system? The review system application contains a huge number of records that keeps on growing. A significant number of write operations being issued to the database, which are made when the user adds a review for a product. A MongoDB is a better choice for both of these situations. These schema-like designs makes the review data flexible, easy to store, and opens up possibilities to later add more fields to the system. That is, the system is not rigid in nature. The location-based options for search and analysis of the product reviews can help by exposing certain patterns and user usage. This can be beneficial if a company wants to invest in a certain product from a particular location. MongoDB also opens up options to scale the data and manage it in a distributed fashion. The fast speed, performance, and the high availability of MongoDB makes it a better choice while comparing it with RDBMS. In conclusion, I would like to say NoSQL databases do not directly replace the SQL databases. Rather, they both work better in some data management problems and address many drawbacks of using traditional DBMS in those situations. In terms of data management and support, both the databases have their pros and cons, and in the end, it boils down to the application itself and which DBMS better fits the use case. Finally, choosing the database solely depends on the business and the user requirements and their preferences. Other features that influence the database selection is the type and amount of data, cost of development, and scalability requirements. Thank you.